Unit 1, Section 5. We're still with two variables. Still reviewing algebra concepts just to make sure we're caught up on those before we hit into these algebra 2s. But we're going to solve by what's called elimination. So, learning goal, I will be able to solve systems by elimination. What do we mean by elimination? Okay, well, that means to get rid of. If you eliminate something, you get rid of it. So we're going to solve these equations by getting rid of one variable by combining the two equations together so that one of the variables eliminates or is taken out as a zero. So it's a method of solving equations by technically subtracting. Horrible handwriting. Let's do that again. There we go. By subtracting the equations to eliminate a variable. Now what I do is I add opposites instead of subtract. Which is really just subtracting but distributing the negative to everybody and then adding the like terms together. So make sure that the equations are lined up. And so what we mean by that is vertically, x is under the x, y is under the y, equals is under the equals, and then the number is under the number. Identify a variable that has the same coefficient. On both equations. What we mean by the coefficient is the number in front. That's what we mean by coefficient. Then we're going to subtract the equations to eliminate. Technically subtract. What I'm going to do is add the opposites. Solve the equation for the remaining variable. Substitute into either equation but the other, or the other, oh, that's not even the word other, that's orther, the other equation to find the other variable and write your answer as an ordered pair. Okay, I do it similar to this, but I don't subtract because I think subtracting is a little weird. Okay, but let's look at what this looks like. You want to line them up. Like these look just like we did in the last section where we did substitution. And why is this and why is this? I don't typically do a elimination in this sense because I could just set one equal to the other and then it's the same kind of moves. But we'll go ahead and do it. Y equals 9x minus 23. Okay, don't need that there. And then I make sure they're lined up. The y, the equals, the x, and then the numbers, the constants. What I'm looking for is a variable that has the same coefficient. So technically the coefficient on the y's is a 1. Okay, great. So I'm going to subtract them. So that means that I'm going to do a negative sign out here and it's to the whole thing. That's what we mean by subtract them. So when I do an elimination, what I try to make happen is that the variables have the same coefficient number, but with a different sign. And you can do that by multiplying the whole equation by a -1, which is what happens when we're subtracting. When I take 1y equals 9x minus 23 and I subtract 1y equals x plus 1, I'm subtracting the whole thing, so that -1 goes to everybody. So what it ends up looking like is 1y equals 9x minus 23, -1y equals -x minus 1, and then all I got to do is combine down. 1y and -1y goes to 0, 9x and -x makes 8x, and -23 and -1 becomes -24. Because they're both negative, it's going to combine. Then I'm just going to solve for x. Add 24. 24 equals 8x. Divide by 8. not by x. X equals 3. So 3 comma something. And then I plug it into one of them. I would do the second equation because it's got the less amount of moves I'm going to have to do. Y equals 3 plus 1. Y equals 4. Okay. So that's what we do. We line them up. We subtract them. Now here's how I do it. I'm going to pull this one straight over because I notice that the y's have the same number, right? They both have a 1. Well, I want them to have opposite signs. So I'm just going to pull this one over. Y equals negative 3x minus 15. This one I'm going to multiply by a negative 1. So I get negative y equals 2x plus 8. And now I'm going to add down. Just combine this way. Y minus y equals 0. Negative 3x and 2x is negative x. Negative 15 and 8 is negative 7. And then solve. Negative 7. And then I'm going to plug it in somewhere. Neither one of them are any easier than the other to solve, so I don't know. I'll pick the second one. Y equals negative 2 times some number minus 8. I know x is negative 7, so I plug it in. Substitute. Y equals 14 minus 8. So y equals 6. Okay. Now, this is the typical fashion that you're going to see the equations written. They're going to be in standard form that you're going to do an elimination for. Back here on these, I know that y equals this thing, so I'm going to plug it in there, and I'm going to solve by setting one side equal to the other side, one equation equal to the other. But this is the way that you'd see it and where you would want to actually do elimination. Now I see that the x's have 1 each, and I see the y's have 1 each, but they have opposite signs. So I'm going to work on eliminating the y's because they're ready to go. All I have to do is combine down. X and x makes 2x. Y and minus y makes 0, so bring down that equals. 3 and 7 makes 10. Divide by 2. X equals 5. 5 comma something, right? 5 plus y equals 3 minus the 5. Y equals negative 2. Okay, so 5 negative 2. Looking at the next ones, the x's are good, the y's don't match up. So I'm going to change the signs of all of one of the equations so that they eliminate. So if I multiply that whole equation by a negative 1, I change the sign here, I change the sign there, I change the sign there. So I got 7x minus 7x is 0. Negative 4y and 10y is 6y equals negative 11 and negative 25 is negative 36. Then I just divide. Y equals 6. So blank comma 6. And then I got to plug it in. I'm plugging it in for y. 7x minus 4 times 6 equals negative 11. 7x minus 24 equals negative 11. Add 24. 7x equals, let's see. Whew. Was it a negative? Oh, look at that. There we go. Now, I started getting weird here because I was like, okay, that's going to be 13, and 13 doesn't divide by 7. And it's unlikely that I'm going to get a decimal or a fraction, so let's check my work. Negative 36 divided by 6 was negative 6. And so when I do negative, that makes positive, so I'm subtracting. They're going to combine, so that makes negative 35. That's better. Divided by 7 equals negative 5. Now they're good. Double check because my math got weird in there, so let's see. 7 times negative 5 is negative 35. And negative 6 times negative 10 is positive 60 equals 25. 25 equals 25. Yes, it does. Okay. We check out. Good. Let's look at this next set. All right. Lined up. X's on X's, Y's on Y's, equals on equals, numbers on numbers. That's good. The y's have the same number, but they don't have different signs. So I'm going to go through and change all the signs of the bottom equation. So that goes plus, that goes plus, that goes minus. And then I'm going to combine them down. 4x and x makes 5x. Negative 2 and 2 goes 0. Negative 30 and negative 5 is negative 35. Divided by 5, x equals negative 7. Negative 7, comma. And now I'm going to plug it in. They all end up with a 2y. So it doesn't really matter. So I'm going to go with negative 7. All right, but let's do that original equation. So let's look at what it used to be. So negative times negative 7 minus 2y equals 5. Negative negative makes a big old plus sign. So I'm going to subtract 7. Negative 2y equals negative 2. Divide by negative 2. Y equals 1. Now, that was in the first equation, so I should plug it in the other one. Let's see. 4 times negative 7 is 28. And negative 2 times 1 is negative 2 equals negative 30. And that's more negative. Negative 30 equals negative 30. Yeah, it does. Okay. Negative 7, 1. Okay. There we go. Now, next one. 3x and 3x lined up, y and y lined up, equals equals lined up, 9 and negative 4 lined up. Now, if you'll notice, 3x and y and then different numbers. The number in front of x is the same, y is both a single, and then the back numbers are different. If we rearrange that into a y equals situation, they're going to have the same slope but different y-intercepts. That means that there's probably no solution. Let's see what happens. I'm going to change the signs of everybody and add down. 3x minus 3x is 0. Y minus y is 0. And 9 and 4 makes 13. So 0 equals 13. No, it doesn't. No solution. Okay. False statement. No solution. If you were to get something where you get 0 equals 0, everything eliminates to infinity and beyond. Now, what if there are no common coefficients? What if they don't have the same number in front? What do we do? Well, we are going to multiply, just like we've been doing by a negative 1 and changing all the signs. Instead of a negative 1, we're going to multiply by a negative something so that we match one of those coefficients numbers but keep different signs so we can combine them down. So, multiply 3 to change the coefficient. So we're going to multiply the whole equation by 3. So 3 times 2 is 6x, 3 times y is 3y, 3 times 5 is 15. So what we're doing is we are not just changing the signs of everything, but we're going to change the signs and the values so that now the coefficients of at least one of the variables is going to line up with the same number, and they'll have opposite signs. So when we combine them together going down, one of the variables eliminates. So we can also multiply by a negative number if we want to. So we change the sign of the variable along with the coefficient of the variable. So negative 2 times x, negative 2x. Negative 2 times 4y is positive 8y. And negative 2 times 7 equals negative 14. So maybe we need to do more than change the sign. Maybe we need to do more than just change the coefficient. Maybe we need to change both. We can multiply by a negative number. So let's see what that looks like. Here, the x's don't line up, the y's don't line up, and we don't really care about the coefficients as long as the equals are equals and the coefficients are coefficients, and the y's are the y's, the x are the x's. We just need one of them to line up. Now, I can't multiply 3 by a number to get to 7, but I can multiply 1 by a number to get to 4. So I'm going to move this equation and I'm going to multiply it by negative 4. Every piece is going to go through the negative 4. 1x times negative 4 is negative 4x. Negative 3y times 4 is going to be positive 12y. 2 times negative 4 is going to be negative 8. And then the bottom one I'm just going to move. 4x 7y, 27. What I've done by multiplying the top one by a -4 is created a situation where I have the same coefficient with different symbols. So when I combine downwards, -4x and 4x goes to 0. 12y and 7y makes 19y. And -8 and 27, let's see, if I go 7 down is 20, one more is 19. Then I can divide by 19, and y equals 1. So I know something comma 1. I'm going to plug it into this original equation back over here, where it was x minus 3 times something equals 2, multiplied times 1. That's my y. X minus 3 equals 2, add 3, x equals 5. Okay? Now, next one. The x's are lined up, the y's are lined up, the equals are lined up, the numbers are lined up. Now I just need to find matching coefficients. None of them do. I got a 7 and a 1 on the x's, I got a 2 and a 5 on the y's. I can't multiply 2 to become a 5, but I can multiply 1 to become a 7. So I'm going to multiply, but not just by 7, but by -7, because I want to change the sign. So this one just comes over. 7x minus 2y equals -32. Get rid of those dots. When I multiply over, x times -7 is -7x. -5y times -7, negative, positive. 5 and 7 is 35y equals -47 times 7, negative is positive. So 47 times 7. 7 times 7 is 49, 28, 29, 30, 31, 32. 329. Now that we've got y's that have the same coefficient but different symbols, we're going to add down. 7x and -7x cancels. -2y and 35 makes 33y. And -32 and 329, 329 minus 32, 7. Cross that. Let's see. Let's see, that would be a 12. That makes that a 2. 12 minus 3 is 9. 297 divided by 33. So y is going to equal, let's see, 297 divided by 33. Mr. Maggart, you could use a calculator. Yeah, but what's the fun in that? 3 to make a 7, if I multiply it by 9, makes 27. So 3 times 9 is 7, 20. 9 times 3 is 27, 28, 29, 297. Wow, look, goes 9 times. So blank comma 9. I'm going to put it in that bottom equation. X minus 5 times something equals -47. Make it a 9. X minus 45 equals -47. Add 45. X equals -2. Just like that. All right, we've got a set for you to try yourself. So take a pause, take a try, come back and see how they go. All right, 3 can't become a 5. But 2 can become a 4, so I'm going to multiply this guy by not just 2, but -2. 2 times -2 makes -4x. -5y times -2 goes positive 10y. And 39 times -2 is negative. 30 twice is 60. 9 twice is 18, so 78. And we just move this one over. 4x, 3y, minus 3y equals 43. Now they're lined up. The x's have same coefficients, different signs. Add down. 4x and -4x and 4x cancels. 10y minus 3y is 7y. And -78 and 43, well, it's going to end up negative because 78 is bigger. 8 minus 3 is 5. 7 minus 4 is 3. That's good. 7 goes into that. Y equals -5. Blank -5. Perfect. We're going to plug it in somewhere. Doesn't really matter. Let's say 2x minus 5 times -5 equals 39. 2x plus 25 equals 39. 2x, oh, nope. got to do something first, don't I? Okay, minus 25, both sides. 2x equals 0. 9 minus 5 is 4. 3 minus 2 is 1. Divide by 2. X equals 7. We get 7, negative 5. Okay. Let's see, 3 can't be a 4. We'd have to multiply both equations. But 1 can become a 2. And multiply by negative 2 again. 4 times negative 2, negative 8x. Y times negative 2, negative 2y. Negative 16 and negative 2 makes positive 32. And then we're just going to bring this one over. 3x is 2y, negative 17. Add them together. Negative 5x equals 32 minus 17. It's going to be positive. 3 up to 20. 10 up to 30. 13 plus 2 more is 15. Divide by negative 5. X equals negative 3. We're almost there. I'm going to pick the one where y is by itself. So 4 times negative 3 plus y equals negative 16. Negative 12 plus y equals negative 16. Add 12 to both sides. Y equals negative 4. Mr. Maggie, do I have to show all your work? Yeah, you have to show all your work. Now, what you can do is check your work. And I do want you to practice this way because you have to do algebraically when we get to 3 variables in the next section. But you can check your work with 2 variables. All we have to do is do 4x plus y equals negative 16, and 3x plus 2y equals negative 17. Where do they touch? Ooh, they got negative 5 for. Did I math wrong? Very interesting. Negative 3. Oh. Interesting. Very interesting. Negative 2. Yeah. I get negative 3. Did I type my equations wrong? 3x plus 2, oh, negative 7. Hello. And there we go. This is why doing the graph in calculator doesn't always benefit you. If you don't type it in the calculator right, the calculator doesn't give you right answers. It only does what you type. So make sure you type right if you're going to type in a calculator. But I'm pretty sure I trust my math. All right, let's check this one out. We'll try this one together, then you can try the next one after a pause. Let's see. I'm going to pick the y's. So I'm going to multiply by negative 5. This one draws over. Negative 3x plus 5y is negative 24. And we're multiplying, so don't forget to multiply through. 2x times negative 5, negative 10x. Y times negative 5, negative 5y. 16 times negative 5 equals a lot. Let's see. Negative 5 times 10 is negative 50. Let's see. Well, we know it's going to be negative. 10 times 5 is 50. 10 times 6 is 30. 50 and 30 is 80. There we go. Add down. Negative 13x. Goodbye. Equals. Ooh, there we go. Negative, is that 104? Drop the 4, 8, 9, 10. Yeah, it is. By negative 13. I'm going to guess that it's 8 times, but let's check. 8 is 4, 28, 9, 10. Yep, 8 times, good. 8 comma something. I'm solving for y. I'm going to pick the one with 1y. So 2 times 8 plus y equals 16. 16 plus y equals 16 minus 16. Y equals 0. 0 is an answer. 0 is an option. Because remember, 0 is right here. 0, 0. 0, 8, 0 would be all the way out here at 8, comma 0. So 0 is a place, 0 is an answer. It is okay. Give it a pause. Try your own on the next one. Come back, see what you get. Okay. I noticed that the y's, 1y can become 3, but 2 doesn't get to go to a 7. So I'm going to bring this one, 2x minus 3y equals negative 20. And I'm going to multiply that one by a negative 3. 7 times negative 3 is negative 21x. Negative y times negative 3 is plus 3y. Negative 13 times negative 3 is positive 39. Add down. 2x and negative 21x is negative 19x. And the difference of 39 and 20 is 19. Divide by negative 19. X equals negative 1. I'm going to solve for the one that has just a y. So 7 times negative 1 minus y equals negative 13. Negative 7 minus y equals negative 13. Add 7. Negative y equals negative 6. Divide by negative. Y equals 6. Okay. If we need to, we can graph them, double check. Let's see. See if I can type it right this time. 2x minus 3y equals negative 20. 7x minus y equals negative 13. Negative 16. Mr. Maggart, it's so easy to just graph them in Desmos and see where the answer is. Why don't we do that? Why are we doing all this algebra? Because if you can do it in 2 variables, the 3 variable one is going to do this, but like 3 times. So we want to be able to do it in 2 variables first, then we're going to move into the next section and do it in 3 variables. Now let's look at some other situations here that might happen. Okay, I see this. Go ahead and give these a try. Let's see what you get. Remember, if you come up with no variables and a true statement, it's infinity. If you come up with no variables and a false statement, it is no solution. They'd be parallel lines. So give these a try. Come back and see the answer. All right, here we go. 2 can't be 5, but 3 can be 9, so I'm going to multiply by negative 3. Change the sign and the number. 2x times negative 3. Don't forget to go through your times, everybody, not just the y. So negative 6x. Negative 3 times negative 3 is negative 9y. 1 times negative 3 is negative 3. That'll be the thing you make the mistake on the most. You'll just multiply the one that needs to change the coefficient, and you won't multiply the others, and then your math will be off and you'll get a wrong answer. It's always good to check your answers too. We can just pull this one over. 5x plus 9y equals negative 2. We're going to add down. Negative 6 and positive 5 is negative x. That goes to 0 equals negative 5. And then all we have to do is go bloop, bloop, multiply by a negative, divide by a negative, whatever it is. We needed x to be positive. It means we change everybody's signs. X is 5. Now, there's not really either one of those. It's easier to plug that in and solve for y. So I'm just going to do 2 times 5 plus 3y equals 1. 10 plus 3y, it's a y, hello, equals 1 minus 10. 3y equals negative 9. Divide by 3. Y equals negative 3. It should work out that if we plugged in 5 next to the 5 in the bottom equation, 5 times 5 is 25. Plug in negative 3 times that is negative 27. Negative 2 equals negative 2. It does. Checks out. So we were right. 5, negative 3. It wasn't no solution. It wasn't infinite solutions. It was one solution. Different slopes, different y-intercepts. This last one. What I see is a 2 can become a 4 and a 1 can become a 2. So it doesn't really matter. I'm going to multiply the bottom one by a negative 2. Top one just comes across. 2x plus 4y equals 9. X times negative 2 is negative 2x. 2y times negative 2 is negative 4y. I think you see. 5 times negative 2, negative 30. 0, 0, 0 equals. 9 and negative 30 is negative 21. 0 does not equal negative 21. No solution. That means they're parallel lines. Okay? Line them up. X's, Y's equals numberses. Figure out which one you can make the coefficients match with different signs. If you need to multiply the whole equation by a number or by a number and sign change, do that. Make sure that you get one letter that has the same number, different signs. Add down, solve, plug it back in, solve for the one that's missing.